Intermolecular forces, IMF. These are the forces between the molecules, covalent compounds, that attract each other in liquids and solids. So what holds a liquid and a solid together are intermolecular forces. Gases do not have intermolecular forces. So if you think about it, if you have water, liquid water, what's holding the water molecules together is the intermolecular forces. And if you break them, they become a gas. So gases have zero or none intermolecular forces. There are three types of intermolecular forces. One is London dispersion. 2, dipole-dipole. 3, hydrogen forces, otherwise known as hydrogen bonds. As you can see here, I've underlined both dispersion and dipole. From this point on, I'll be calling London dispersion forces, and I'll be calling dipole-dipole forces just dipole forces. In this picture, you'll see that I've circled the intermolecular force. These are all water molecules. I have 5 water molecules shown in a pattern. Now, when water freezes into a solid ice, it forms this crystalline pattern. Now, what holds those water molecules just like that is the hydrogen bonds, a type of intermolecular force. Imagine breaking those intermolecular forces, and you'll notice that one of those water molecules will be set free. This is how we turn water to a liquid into a gas. When those intermolecular forces are loosened, it becomes a liquid. When they are fully broken, they become a gas. This is a picture for the dispersion forces. At the very top, you'll see iodine. Iodine is a diatomic, which makes it nonpolar, as you can see. Now, towards the bottom, you'll notice that iodine has changed shape, and so that it has a partially positive and a partially negative charge. When iodine does this, it attracts other iodines together, and they stick together to form liquid iodine or solid iodine. Dispersion forces are the weakest, they're temporary, they form from nonpolar molecules. They break down easily, and that means they're gases at room temperature. Since these are the weakest type of IMF, they don't exist anywhere outside of really cold temperatures. So as the temperature goes up as it goes up, the bonds are easily broken. Diatomics like iodine are held together by dispersion forces. Also, dry ice, like solid CO2, are held together by dispersion forces. CO2 is a nonpolar molecule. If you don't know your nonpolar from your polar molecules, please click on the link to review polar and nonpolar molecules.